Thank you for joining me today. Well, a couple days ago, I was checking some putative haploids, and you can see where I took a sample from there and a sample from there, and I scoped them, didn't find any clamp connections. But the one thing I didn't scope are these white patches, and I haven't seen this type of growth before. It kind of reminds me of this plate where I did a transfer and then I dropped it and it stuck to the lid. So I flicked the lid a couple times and you can see where I cracked it. And what happened is each one of these spots is where that transfer touched. And it left this guy all out by himself because reabsorbed. I'm not really sure what the word is, because some people think you can do this and end up with multiple monokaryons or haploids, but I really don't think you can. I think it's just a genetic copy of the sample, and that's why there's not like a dikaryotic line between these ones. They just kind of absorbed back in, and but that didn't happen to this plate, and it's kind of baffling me because I seen it on another plate. This was a spore drop, and then I took my samples, transferred them to these plates, and they're also showing these white dots and growth. So I was getting ready to make this culture with another haploid, but I felt that I need to check and make sure that these white spots aren't showing any clamps. So I figured it'd be a good day to do some scoping, and how I look for the presence of clamps or the absence of clamps. So I already have my tools sterilized. I have a clean slide. I am using AmScope slides for my cover slips. This is what I'm using for my cover slips. And speaking of these cover slips, I used to struggle with my cover slips. I would add them to a container, I would soak them in alcohol, and I always had to spend hours cleaning them. So I did a post on Alcoholics Anonymous, and Stealthy Spores reached out and gave me this recommendation, and it has been smooth sailing since. So once again, Stealthy Spores, thank you very much. I'm actually on my second run of these. I don't have to clean them, just use them straight out of the box, and it makes streamlining my work in the lab so much easier. So for doing our slide, what I do is I'll make a couple slits, and then I'll try to get a sample off from it that is about the size of a grain. So I just make a slit, and I don't use the full depth of the agar either. Just a little bit, about the size of a grain of rice. And I'll add that to my slide. Take my cover slip, place it over my sample, keep it in the center as much as I can, and then I'm just going to press straight down. And this is called a squash mount, and that's the one reason why I'm wearing a glove, so I don't leave a fingerprint on my cover slip. So I'm going to squish that down. And if you look inside that light ring, right there's our sample. So with this sample, what we are looking for is a lack of clamps. So let's mount this up into the microscope and take a look. So I'm going to start off on the lowest magnification and work our way up until we can get a clear look at the septa. Here's a diagram, and so this is the hyphae that we're going to be looking at. Throughout the hyphae, you're going to have these compartments, and they're divided by the septa. Like the lipid bodies, crystals, nucleus, all this stuff we won't be able to see, but we will be able to see the vacuoles, the septums, and the hypha walls. So let's get our sample in here. So you can start seeing, this is the sample that we did the smash mount on. And you can see, as you go further away from the sample, it's not so dense with overlaying hyphae. So we probably can get a better look at our septas more down here. Now I just went up to the next magnification. You can see a little more detail. The final magnification that we will be looking is 1000x. So let's switch over to 1000x right now. And let's look for a septa. So I think that's our first septa right there. No. See that what this is, sometimes these vacuoles will look like a septa because they're basically a large membrane with cytoplasm in it. And they basically store nutrients and waste products and other substance. And they also help maintain the structural integrity of the hyphae. But sometimes they will look like a septa, so you have to zoom in and zoom out to kind of get an idea. So you can see up here, this is a septa. And these are vacuoles. So let's do some more. So we're doing pretty good. We found one septa. Oh, there we go. Got another one coming into the... And then here's another septa with no clamp. So we're doing good. And what I'm going to do, we're going to go to 15 and then we're going to call it so we can look at another plate. See, there's a septa. And that one looks like it's a septa, but it's one of those membranes inside the hyphae. There's another septa right there. So I think that's 3. There's another septa right there, 4. There's 5, 6, 7, 8. There's another one here, I just can't bring it up. Nine. 10, 11, 12, 13, 14. Now I'm going to go all the way to the other side of the sample and get our last one. I like to look all over the sample. There's our 15. So that confirms that this plate, even though it has these extra growths on it, this different type of mycelium, that this plate is now triple confirmed to be haploid. So I can use that in my breeding projects, because this plate cannot fruit a mushroom. It needs another nucleus, and that's why it's a haploid, monokaryon. It can't fruit. Now that we have confirmed that this is a haploid, let's look at a diploid. So this plate is my T1 plate, and this is my T0 plate, which you can tell by the grab and drag. So you can see how it's all mated up, and this plate, I can send it right straight to grain because it will fruit. Let's take a look and see what the clamps look like. Got a nice clean slide. Got my sterile scalpel. And let's look for an area that doesn't have much overlay. Right in here is where I'm going to take a transfer later on, because it's very rhizomorphic compared to the rest of the plate. So let's go up in here. Just make a little box. And just get underneath the surface. About size of a grain again. Place your sample on your slide. Get your cover slip out. Center it over your sample. Push down in the center. I missed. The phone is kind of obscuring my vision. Alright, so we got our sample in the center. Right there's the sample in the center, and we'll mount that into our microscope. Alrighty, we got our slide in the microscope. Let's start out in the lowest setting. Look at all those hyphae. And we'll get an idea where it starts. And that's what I look for. Like during the middle of a smash mount, a lot of times it's so overlaid that you really struggle to look for clamp connections. But if you move to the outskirts, you can see how it's not so dense, and that's where we can observe a lot easier. So let's start in here. Now we're going to go up on our objective. And we'll bring it into focus. Give you a little better look. And let's go up to 1000x. So what we're looking for here are clamp connections. So I'm going to try to find a good one. See if we can find a big old fat hyphae. I thought that was one right there, but kind of has the shape of it. There we go. So right there is a clamp on a septa, and then over here is a clamp on a septa. And we can tell that it's a clamp because this is what the clamps look like. You can see the septa. This is the septa, and this is the clamp going from this side over to allow a nucleus exchange. So then it will dikaryotize, and once you have two nucleuses, then this mushroom will produce fruits. So we found two, and a lot of people would just leave it as that. Like if you're looking for, like if I was scoping this plate and I seen that, all I gotta do is see one and I'm done. That means I don't have a haploid. So haploids, no clamps. Diploids have clamps. So let's look for a couple more clamps. Even though we just found clamps, that doesn't mean that all septas are going to have clamps. Like this septa here does not have any clamps, but you can see inside we got some movement. I doubt that those are nucleuses. They're probably either smaller vacuoles, lipid bodies, or crystal. But I'm not 100% sure. But they seem to be partying in there. Maybe they're setting up to make a clamp. Kind of checking out each other's vibes. There's a beautiful one right there. Come on, baby. Look at that clamp. It almost looked like a double clamp at times. Sometimes you can have a clamp on this side and a clamp on that side. And I always wondered if, when you see double clamp, is one clamp going this way and the other clamp's going the opposite way, or are they both going the same way? So now we know that we can add this plate to our grain and be able to fruit it. So let's go back over to our purified flow. So I am done scoping these plates. So the next thing I'm going to do is I have some high nutrient and low nutrient plates. So let's see how this haploid grows out on one of each. So the high nu plate. So these are all, I can wrap these. Sometimes I'll get heavy condensation, so I'll stick a pack of desiccant packs in a container and pull out that extra moisture. So I'm gonna go get I gotta get a low nutrient plate. Take my sterilized scalpel. Play shuffle around. I'm going to go try to get out towards the leading edge as much as I can. And then let's put one on high nutrient. So there's our samples. I'm going to mark that I check this again. So it gets a 0 with a line. That means haploid, no clamps, 0 clamps. And this culture is one that was given to me by Michael Geeky called Timbit. And I'm excited. I got clamps, so I'm going to have fruit soon. And I'm excited to grow this culture that I've never grown before, and I'm grateful that I got the opportunity to grow it. So that's all I got today. Looking at clamps, doing a little bit of detective work. I have a lot of experiments and projects getting ready to share. So if you have any suggestions or you want to see something done in the lab, give me a suggestion. I love experimenting, and I love learning and sharing what I learned. So have a great day. Like and subscribe, and we'll see you on the next one. Thank you very much. Have a great day.